Hi everyone. Today we are going to be talking about factoring. First, we're going to start by finding the greatest common factor, also known as the GCF. Next, we're going to look at how to factor out a common factor, and then finally, binomial common factors. Okay, grab a piece of paper and a pencil, and let's get started. Okay, so the first example, first we're going to define, well, what is a common factor? The greatest common factor, GCF, of a set of whole numbers is the largest positive integer that divides evenly into all the numbers with no remainder. So if we're looking for the greatest common factor, the GCF, between 18 and 30, so what we're going to do is we're going to make a list of all the factors of 18 and then all the factors of 30, and then we're going to look for the highest number that's common between those two sets. Okay, let's go ahead and write down our factors. Okay, so the factors of 18 are 1, 2, 3, 6, 9, and 18. Next, let's go ahead and look at our factors of 30. Okay, so the factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. So if we look for the greatest common factor, the highest number between the two, well, 1 and 2 are factors, but it's not the highest common factor. 2 is a common factor, 3 is a common factor, 6 is a common factor, and there's nothing after 6. So that means that 6 is the greatest common factor. So I'm going to go ahead and circle my GCF of 6. So GCF equals 6. Okay, let's look at our next example. Next, we're going to look for the greatest common factors of 12 and 20. So the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Okay, let's go ahead and write down our factors of 20. Okay, so the factors of 20 are 1 and 20, 2 and 10, and 4 and 5. So if we look at the greatest common factor between the two, it's 4. So my GCF is equal to 4. Okay, let's look at our next example. We're going to look at some more complicated greatest common factor problems that include algebra. So this time we have x squareds and y squareds. So first we're going to start with the coefficients, so the 45 and the 36. So what's the highest number that's common between the two? So if you need to write down your factors of 45 and 36 separately, go ahead and do that. Okay, so to get started here, what we're going to do is we're going to write down numbers that multiply to give 45. So 9 and 5 give 45. And then I'm going to write in expanded form. So I have x, and I have another x, and I have two y's. And then if I look over here at my 36, two numbers that multiply to give me 36 are 6 and 6. And then I have four x's. Two y's, and a z. So I can further break down the 9 to 3 and 3. And I can further break down the 6's to 3 and 2. So this is just another way to look at your factors. So if I look for the things that are common, I can clearly see that I have two 3's that are in common. I have two x's that are in common, as well as two y's that are in common. So that means my GCF, or my greatest common factor, is, well, 3 times 3 is 9, x squared, y squared. So eventually we won't need to write it out longhand, but for now, we'll just kind of look at it that way, just as another way to show that we have expanded and found our GCF. Okay, let's look at another example here. This time we're going to factor out the greatest common factor, and it's also referred to as common factoring or common factor. So first we're going to determine the GCF of each term. Next we're going to write the GCF in front of our bracket, and write the remainder of each term inside the bracket. Let's look at our first example. So we're going to factor out the greatest common factor, or in other words, common factor, 2x cubed y to the exponent 8 plus 6x to the exponent 4 y squared plus 10x to the exponent 5 y to the exponent 10. Okay, so if I look at the coefficients, so the numbers in front, the greatest common factor there is 2. So let's start with that. So GCF, so the 2. Next I'm going to look at the x's. So the highest x value that's common to all three terms would be an x cubed. So I'm going to next write x cubed. And then I'm going to look at the y's. So the highest y value that's common to all three terms is a y squared. So what I'm going to do next is I'm going to write that 2x cubed y squared, so my GCF, in front of a bracket. And what I'm going to do next is I'm going to divide each term by that GCF. So think back to your exponent rules from grade 8 and 9, right? So if we divide 2 by 2, well, we get 1. X cubed by x cubed is just 1. Y to the exponent 8 divided by y squared, well, we subtract our exponents and we get y to the exponent 6. Next, we're going to look at our second term. So 6 divided by 2 is 3. X to the exponent 4 divided by x cubed is just x. Y squared divided by y squared is just 1, so I don't need to write the 1. Then we're going to look at our third term. So 10 divided by 2 is 5. X to the exponent 5 divided by x cubed is just x squared. And then y to the exponent 10 divided by y squared is y to the exponent 8. So just remember, when you are dividing using the quotient rule, we're going to subtract our exponents. Okay, let's look at our next example. Okay, we're going to common factor 15x squared y plus 5xy squared, subtract 25x cubed. So again, we're going to start with our GCF by looking at the coefficients. So there's a 5 that's common to each of those three terms. Next, we're going to look at the x's. So the highest x that I can divide out of each term is just x. And then I'm going to look at the y's. I can't actually factor out a y because there is no y in the third term. So 5x is my greatest common factor. Okay, so now we're going to write 5x in front of our bracket, and we're going to divide each term by 5x. So 15x squared y divided by 5x. Well, first 15 divided by 5 is 3. And then x squared divided by x is x. Y divided by, well, 1 is just y. Plus 5 divided by 5 is 1, so I don't need to write the 1. You can if you want. X divided by x is 1. Again, we don't need to write the 1. So then we're just left with y squared. Subtract 25 divided by 5 is 5. Then x cubed divided by x is x squared. And that's it. Okay, let's look at another example. The next series of question is binomial common factoring. So we're going to factor out a common binomial. So if you look at each of those segments, those parts, those factors, we have a common x minus 4 that's in the bracket. So what we're going to do is we are going to think of that as our GCF. So our greatest common factor is x minus 4. So I'm going to put the x minus 4 in front of my bracket, and then I have 2x minus 3 inside my bracket. And because there is two terms for the GCF that are separated by a subtract sign, I'm going to put that in a bracket. If we were to check by expanding using FOIL for our answer, and then if we were also to expand our original equation, we should get the same solution when we do that. Let's go ahead and do a check just to verify this. Okay, so I'm just going to go ahead and expand. So 2x times x is 2x squared. 2x times negative 4 is negative 8x minus 3x plus 12. And combining like terms, we have 2x squared minus 11x plus 12. And now I'm going to check my answer. So I have x minus 4 times 2x minus 3. And again, using FOIL, so x times 2x is 2x squared. X times negative 3 is negative 3x. Then we have minus 8x plus 12. Combining my like terms in the middle, 2x squared minus 11x plus 12. So if you look at my left side and my right side, they match. So that means the answer is in fact the x minus 4 times 2x minus 3. Okay, let's look at another one of these binomial common factoring examples. Factor out a common binomial. So this time we have x minus y in the first bracket. The second bracket, we have negative y plus x. We can actually physically switch those two terms and rewrite it as x subtract y in the second bracket. So I'm going to start with doing that. So 5x, x minus y, that part didn't change, plus 8. But as my last bracket, I'm just going to rewrite it as x minus y. So I'm allowed to switch things without changing the signs. I haven't really done anything different except for rewriting it so that it actually looks the same as my first bracket in my other example. So now that we've rewritten this as 5x times x minus y plus 8 times x minus y, I can think of my x minus y as my GCF. So then we have x minus y in front as my GCF and 5x plus 8 as the other factor. And that's it. That's all we can do. Okay, the last series of questions we're going to look at is factoring by grouping. So we're going to group terms together that have a common factor. So we're going to factor each group to try to get a binomial common factor, just like the previous series of questions that we looked at. So you'll notice here that we are starting with 4 terms. And what I can notice here is if I split them in half, so I'm just going to kind of draw a little squiggly line down the middle here. In the first 2 terms, I have a common c. So the greatest common factor of the first 2 terms is c. And then I'm going to divide out c by each of those terms. So ac divided by c is just a. bc divided by c is just b. I'm going to leave the plus sign in the middle, and then I'm going to look at the next 2 terms to see what's common. Well, I have a d and a d that's common. So my greatest common factor is a d, and then ad divided by d is just a, plus bd divided by d is just b. So now I can see that just like the last series of examples, we have a common factor of a plus b. So a plus b times c plus d. Okay, and that's it. Okay, let's look at our next example. So this time we actually will have to do some rearranging for our terms. So I need to get a common factor for the xy. So I could move either the 4x or the 3y. I'm going to start by moving the 4x. Sometimes we guess wrong the first time. And I'm going to move my 12 over to the other side. So I have xy plus 4x plus 3y plus 12. The signs stay the same because there is no equal sign that we're moving things across. So we don't need to worry about switching any signs here. The signs just stay the same. So I'm going to go ahead and split my question into 2, just like I did with the previous example. Okay, so if I look at my first 2 terms, I have a common x. So I'm going to go ahead and write my GCF of x in front, and I'm going to factor out a y plus 4. I'm going to keep my plus sign in the middle, and then if I look at my next 2 terms, the greatest common factor is a 3. 3y divided by 3 is y. 12 divided by 3 is 4. So if you guessed wrong, for example, and you put the 3y next to the xy, you would just notice that the terms inside the bracket don't match. And so then you would have to just kind of go back to the drawing board and rearrange the other way. Okay, so here I can see that I have a greatest common factor of y plus 4 when I'm looking at these. So y plus 4, y plus 4. So I'm going to rewrite this as y plus 4 in my first bracket, and then x plus 3 in my next bracket. And that's it. Okay, let's take a look at our next example. So I'm going to see if I can leave the terms where they are. So I'm going to go ahead and split my equation down the middle and see what happens here. So the GCF here would be 5m squared, and then I would be left with t minus 2 plus, and over here I have a t, and then t minus 2. So actually we are in luck. We have a GCF of t minus 2. So t minus 2 times 5m squared plus t is the answer. Okay, that's everything for today. Thank you for your attention. Have a great day. Bye-bye.